Students, you are on to Dr. OJ tutorial class. In this video, we shall be discussing differentiation from parametric equation. Stay blessed. Now, what are parametric equations? Parametric equations are equations that contain a parameter being used to, to show the relationship between one variable and the other. Now, we often define y as a function of x in most cases, but it is also convenient to express both y and x as a function of a third variable known as t, as in third variable t, which is known as a parameter. Now, generally, y is equal to f of t and x is equal to psi of t. Yes, generally defines y as a function of x. This particular equation defines y. So if y is equal to t squared and x is equal to 1 over t, obviously from substitution here, we will say y is equal to t squared and x is equal to 1 over t. By substitution here, this one can be, this t will be 1 over x, this one. Yes, if you cross multiply, t will be 1 over x. By the time you put it here, y will be equals to 1 over x all squared, which will be 1 over x squared. Okay, it is convenient to write it that way because we have introduced a parameter t, and that is directly by substitution. But it's not always easy to, to substitute directly like that. It's not always easy. So what do? Now we are going to find the relationship between x and y with respect to t. So now let's say that we have dy dx. We always find the derivative of y with respect to x using a function of function, while the other one will involve a direct product. So dy dx will be, let's say, dy dt dot dt dx. This is an interpretation. The y dx can be, if you can define y with respect to x when you have dy dt multiplied by dt dx, which is the same thing as saying dy dt all over dx dt. This means the same thing. If you divide, you have that. Now, let's look at an example to illustrate our explanation clearly. Find dy, let's call it example 1. Find dy dx when 1, y is equal to t squared and the x is equal to 1 over t. Beautiful. Now, how do we go about this? Should we write the, okay, let's write the second, let's write the two questions at the same time. Second question, y is equal to sine theta, x is equal to cos theta. So now let's solve the problem. Let us solve the problem. Now, looking at the first one is a function, y is a function of t, while the second one is also x is a function of t. How do we now find dy dx? Fine. Let's solve this. Picking it from the dy dt here, dy dt is, if you multiply this is 2t, differentiating y with respect to t, 2 times 1 here, 2. Then you subtract 1 from 2, you have t raised to power 1. So it's 2t. And your dx dt here, if you differentiate x with respect to t, this 1 over t is like t raised to power minus 1. Sure, according to the law of indices. So that means we now have minus 1 t raised to power minus 2. So you have minus 1 times 1 over t raised to power 2. That's minus 1 over t squared. Okay? And so from our formula, from dy dx is equal to dy dt times dt dx. Okay? So we have dy dx will now be dy dt 2t, we have 2t, multiplied by dt dx. we got dx dt. So that means that we have to find the inverse of that. That is, dt dx will now be times the inverse of 1 all over minus 1 over t squared. Yes. Minus 1 over t squared. So that will give us dy dx will be 2t multiplied by minus t squared. So we have minus 2t raised to power 3. That's it. That's it. That's it. So now the second question. Second question. Y equals to sine theta, x equals to cos theta. Fine. Let's differentiate y with respect to theta. The y be theta be cos theta. Then let's differentiate x with respect to theta. The x be theta be minus sine theta. Beautiful. Okay. Now, you know our question says we should find the y dx. Okay. It has to find the y dx. So therefore, the y dx is the y d theta times the theta dx. Yes, because we can't say the y dx, the y d theta times dx d theta. No, it will not work because it will cross out to give us the y dx. I hope you understand. It must cross out. What is on the left should be on, what is on the right should be on the left. Okay, so this will be dy d theta is cos theta multiplied by d theta dx. Mind you, we got dx d theta and we need d theta dx. It's just the inverse of, when you turn it upside, it's also minus 1 over sine theta. Okay? Alright. So that will be minus cos theta over sine theta. This is minus cot theta. Because cos theta over sine theta is cot theta. So that's that over that. Now let's look at another example here. Let's look at another example. Let's look at another example. Example 2. Find the y dx and the square y all over dx squared. Are the points with abscissa 1 on the curve y equals to 1 over t, x equals to 2t. Now, how do we solve this? Fine. It's not difficult, just have to take our time. Now, the y dx, from what you have learned, the y dx will be the y dt times dt dx. Yes, that's how it should be. So that when it cross out, this is like function of function. And I told you. So, now, the abscissa here means when x is equals to 1. That's the abscissa. Abscissa means the value of x on the plane, in the graph, x average. Okay. So now, since y is equal to, this 1 over t can be written as 3 raised to minus 1. Yes. So dy dt will be minus 1 t minus 1 minus 1 minus 2. Okay. So that would be You can write it as minus 1 all over t squared. Yes, because this minus 1 is this one. Then times 1 all over t squared. So it's everything will be minus 1 over t squared. You get it now? This one is minus 1 times 1 all over t squared. The minus here is for this 1 over t squared. Then this minus 1 originally is this. So minus 1 times 1 is minus 1 all over t squared. Okay? Well, now, how do we get the t dx? You know, in the question given to us, x is equals to 2t. So now, since x equals to 2t, the x dt will be 2. So the t dx now, the inverse of this, will be 1 all over 2. Okay. Now, so that means that, therefore, dy dx, which is the y dt times the t dx, will now be the y dt, we got what? Minus 1 all over t squared times the t dx is 1 all over 2. So that will give us what? Minus 1 all over 2t squared. And in the given expression, we actually, okay, so we get minus 1 over 2t squared. Fine, beautiful. Now, in the given expression, our x is equals to 1 because we have to replace this t. So that means from x equals to 2t, so we have 1 equals to 2t. So 1 all over 2 will be t. That is when the variable side by 2. You know, this is it. And we are given the value of, because we are asked to find at the point of that x is equals to 1. So t will be equals to half, which means minus 1 all over 2 into 1 over 2 squared. It's minus 1 all over 2 times 1 over 4. That's minus 1 all over 2. I think minus 1 all over 2. This is 2 times this. Okay. So by the time you invert this, sorry, this minus 1 over 1 over 2. That's minus 2. That's minus 2. That will be minus 2. Because 2 here, 1, 2 here, 2. So it will be half left. Minus 1 over half. That's when you invert half, you have minus 2. So now, how do we now get the square y dx square? I hope I can clean this now. Anyway, when we need anything, we consult the question again. Now, how do we now find the square y dx square? The square y dx square is the same thing as d dx of the y dx. Yes. You want to differentiate again. Again. And this could be the same thing as d of dt, that is the y dt, of dy dx times dt, dx dt. If you put dx there, it will work. This will cancel it. This will be y dt. No, it should be dt dx. It will not work. Beautiful. Yes. So dt will cancel dt. This is y. So it works. Yes. That's it. That's very good. So now, which is the same thing as you can write whichever one we want to write. We can replace this and this and put it there. No problem. So we can put the t. Oh, is all right. This is like d of, this is like dy dt of dy. You understand? Fine. Now, since from our given problem, since let's look at it, dx dt, which we have done before, is 2. I hope you are following. Then dt dx will be 1 over 2, the inverse of this. Just following what we have done before. Okay. So, what other things we need? We have gotten this one before. Dt dx we have gotten. Dy dt is what we are looking for. So we can write this as, this one could be written as dt dx of d of dt of the y dt. Beautiful. I mean the y dx. I just brought this one here now. I rearrange. That's just it. Okay. And d of dy of, you know, we have gotten the y dx before. We now differentiate it with respect to t now. Yes. What we have gotten as the y dx before we substituted for the value of t to be half. Do you understand? We will now find it with respect to t. It's not difficult. It's very simple. Come on. Yeah, let's go ahead. We have known dt dx as what do we get here now? 1/2. This half, dt dx is half now, into d of dt of dy dx. Because we have gotten this already, which we have just gotten. Now, and what was our dy dx? We have to check that. I think we got dy dx to be 1 minus 1. So you have that will half d of dt of, I think, minus 1 all over 2t squared. Yes, that's what we get before. Yes, we've gotten this before. So which means that, let's first of all deal with this one with respect to t squared. You know, this one is like minus half t raised power minus 2. That's the meaning of this. Check. If you extract the fraction minus half, you have t raised power 2. You know it's a denominator. When it comes up, it becomes negative. So if you now differentiate with respect to t now, okay, that's minus 1 over 2 times minus 2, then t minus 2 minus 1. Yes, now you take this index, multiply the coefficient of t here. So minus half times this minus 2, then subtract 1 from minus 2. So this one will cancel this one out. You have minus and minus plus. So you have t raised by minus 3. Fine. So we are almost there. We are almost there. T raised by minus 3. T raised by minus 3. So that means this has now become 1 all over 2 times t raised by minus 3, which is 1 all over 2 times 1 over 3 raised by 3. That's the meaning of d square y dx. So you know, we originally started from here. We expanded it to here. That is d square y dx squared is now equal to this. So, and at t equals to half, we have the square y all over dx squared to be half times 1 over 2 raised by 3. Yes. So that will be half times 1 over 8. It's half times 8 over 1, because that will be 4. So with this we have come to the end of differentiation from parametric equation. Do well to click on the notification bell so that each time I upload a video, you'll be daily notified. Thank you.